welcome to today's maths lesson. So our focus is going to be finance and growth. In particular, we're going to look at what it means to have growth. But before we do that, I'm going to ask you a few questions that I want you to please think about, so that when we're talking about this concept of simple growth in particular, then you have things that you are busy thinking of as we're busy with this lesson. So let's just jump right into it. So firstly, I will ask you, have you ever thought about how you would describe what growth is? So that's something just to pause and think about there. And also, what exactly is growth? Now, if you look at this here, you can see that we are looking at a pot, right? And this is a plant pot. So initially, this is what I have as my plant there. And then over time, my plant goes to that point. And over time, my plant goes to that point. So you can see that there is a change in terms of the plant that I have here. And that's one example of what growth would mean in this context. Also, how would you then describe growth in words? So when you're talking about describing growth in words, can you then say what change exactly is it that you are trying to look at? Is your change constant or is your change random? And exactly in how long or in what intervals is the change happening? So that's what you would need to talk about if you want to describe your growth in words. Now, let's also look at this particular tree here, right? So if I look at this, over time, you can see that these circles of ours here, they are growing gradually so. And as they are growing, normally it grows through years. So this is a yearly growth. So in this instance, we then call this the rate of change, right? Rate of change meaning it's change with respect to years, because a tree would grow each and every year. So every year it becomes a bit bigger, a bit bigger, a bit bigger. Hence, we always just cut it now and again. So this is one also example of what growth would actually mean. Now, let's now pin this down to what exactly we want to try and talk about, describing growth using mathematics. I want you guys to now look at this particular graph that we have here. It shows the weight of different babies for 30 months. So as you can see on this particular graph that I have here, on the x-axis here, I have the age in months, and on the y-axis, I have the weight in kgs. And over time, you can see that the person will start having maybe a weight between 2 and 4 kgs. One thing you need to know here is we cannot start the weight at 0 there, because we can't say a person started having weight as 0 kgs. That is a baby for that matter. So they start there and gradually it grows over the 30-month period. And then the other baby can start maybe having a growth of 4 kgs, which will grow gradually until it gets to roughly there maybe 15 kgs when they are 30 months old. And now what I want you to look at is when you're talking about growth, you need to look at whether there is a pattern, and also can we develop a model to predict the growth. So when you're talking about a pattern, from this initial point to the second point, to the third point, to the fourth point, is there a constant pattern that we can look at? Is there maybe an exponential pattern that we can look at? Or is there just a random pattern that we can look at? And if there is a pattern, can I then develop a model such that if I was to be given maybe 100th term, I can find out what exactly that term is going to be used based on this model that I've created at that time. So that's what we are actually talking about here. Is there a pattern? Number one. Two, can I develop a model to predict something that might happen in future? Now, to pin this down, we're going to use a concept map. Our big idea is growth. And under growth, we're going to look at what patterns that the growth follows. And we're also going to look at growth in terms of graphs, as I've shown you with the previous example. And we are also going to look at equations. Equations would then be the model that I just explained now, whether we can develop a model to explain the growth that we want or to predict this growth that we are talking about. And then we're going to also pin this growth in terms of context. One will be society, and then it will be finance. So finance will be the main big idea that we are trying to get to. But before that, we are going to look at this under society as our context. Now, let's first look at the first concept, which is patterns. Now, under patterns, I have either simple, compound, or random patterns. Now, our simple pattern would be where there is a constant growth that is happening with my pattern as I am moving from one term to the next. And with my compound growth or my compound pattern would mean it is a constant, but not necessarily that I'm adding it. It would be I'm multiplying by the same value going forward. And then there will be a random pattern where it does not follow a specific pattern, but you can see when you're looking at the pattern that there is some form of pattern there. Now, with data, it's either going to be equations and graphs. So we're going to use patterns to talk about equations, number one, and then also to pin this down to our graphs. Now, specifically, let's look at simple growth. Now, there are keywords that I'm going to be giving you guys that you need to look at, please, under simple growth. These would be words that explain what it means to have simple growth, and also what is it that we need to do to try and predict what would happen in the future, being given that this is a simple growth. Now, you need to measure the change that is constant. So if it's a simple growth, we measure change that is constant. And also, this is linked to an arithmetic pattern, which I know that we might be familiar with an arithmetic pattern where we deal with a D, which means there's a common difference as we are moving from one term to the next. Still on our keywords, we also have a rate of change. A rate of change will be change over a certain period of time, maybe yearly, monthly, 2 years, or every 6 months, or every 3 months. That's the change that we are talking about, which is then the rate of change. And then with this, we look at the steepness of a slope. So the rate of change is measured as the gradient. Remember, our gradient will be normally the change in our rise over the change in our run, meaning the change in the y values divided by the change in the x-axis. And that steepness of that slope will then tell us what the rate of change is over time of this particular growth that we are talking about. All right, so guys, that's all that I wanted to just discuss with you for now. I want you to look at, or to think about rather, what exactly does it mean to have growth, specifically simple growth, and what exactly does it mean to have a pattern under growth? Is our pattern simple, compound, or is it just a random pattern? Is there a rate of change that we are dealing with? And also look at graphs, or think about graphs that we'll be dealing with to try and represent the issue of growth and how growth would work in this concept. So one example would be an arithmetic pattern, as you saw, which I will just show you a quick example of what an arithmetic pattern would be, so that you can now think about this as you are thinking about finance and growth, specifically under simple growth. So let's say, for example, with our arithmetic pattern, which I know that most of us are familiar with, it will be, let's say I have 3, and then I have 5 there, I have 7, I have 9. So I will be looking at how does each term grow to go to the next term. And I will be looking at what the difference is between these two terms. So you can see that our difference there is 2, and our difference there is 2, and our difference there is 2. What does that mean? It means, firstly, we started with 3, and then we added 2 to the 3 to get the 5, so it grew with 2. And then we added another 2, meaning it grew by 2 as well. And lastly, we added another 2, which means it grew by 2 as well. So that's the concept of growth that we are trying to emphasize here. All right, so that's it from me, guys. We're just going to go to a quick ad break, and I'll be back with some more. Stay tuned. Hi guys, welcome back. So we are still busy with some finance and growth. In particular, we're looking at some simple growth, and under simple growth, we are looking at patterns. So let's just jump right into it. So remember that we said our big idea is growth, and we're looking at patterns under growth, and then we are specifically looking at a simple pattern or a simple growth, if you would like. Now, I want us to just explore some data. Now, with this data that you're going to talk about, let's say you go to the doctor, and then the doctor says to you, for your health purposes, you need to get to a certain number of steps in a day that you need to walk, because you know exercising at times is a bit of a problem, because maybe some people don't have time, or it's just too much for them. So they then say to you, no, just walk, right? But in your walking, you must get to 10,000 steps. So your goal is to get to 10,000 steps. We're going to look at the first days, because remember, with the first days of you walking or doing any exercise, you're going to start by just doing gradually the very same thing, kind of, just so that you can get the oomph of what you are trying to do, and you can get used to what you are doing in terms of walking or exercising. And then later we'll then look at what happens when you then change things around. So the very first week, the person then decides to say, day 1, I'm going to walk 5,000 steps, right? Then day 2, there is 5,000 steps. So the questions to you would be, was there any change between these 2 days in terms of the number of steps that the person walked? Day 3, you look at, they walk 5,000 steps as well. Day 4, they walk 5,000 steps as well. Day 5, they walk 5,000 steps. So you can see that with the days, as the days progresses for the first week, the person is walking the very same number of steps. So we will then be looking at whether there is change, if our change is constant, if there is change. If there is no change, then what concept are we trying to talk about here? So clearly you can see that with this first example, there is no change. Why? The reason might be the person is still getting used to walking, because they were not used to walking, because I know some of us, maybe we are not really big on exercising, but this might be very good for our health. So they decide to say, no, let me keep on walking 5,000 steps each day for the first week. And then gradually, I will then start increasing maybe my number of steps per day or something like that. So if I then put this on a graph, right? So initially, the person walked 5,000 steps, right? So this would be our day 1. And day 2, you know that they also walked 5,000 steps. Our day 3, they also walked 5,000 steps, excuse me. Our day 4, they also walked 5,000 steps. And then our day 5, they also walked 5,000 steps. So this will then look something like this, meaning they walked the same number of steps in each day for 5 days. When talking about gradient, excuse me, so with gradient here, we'll be looking at whether there is a rate of change that is taking place here. We're going to look at whether the slope is steep or if there is even a slope for that matter, because that's what's going to tell us whether there is a change or not. But we saw that looking at the actual numbers, there is no change. But mathematically, let's then look at what that means. Remember that our gradient is going to be our change in y over our change in x, right? So in this instance, it will be our change in steps, and then this we will divide it by our change in days, right? So our change in steps in this context will then be 5,000 minus 5,000, right? And you divide this. So we can take this day here and we can take that day there. So this was when this person traveled 5,000 on the 5th day, minus when they traveled 5,000 on the first day. So this will be 5 minus 1. So you can see this becomes 0 over 4, which then becomes 0. Why does this then become 0? That's one thing we need to think about. It tells us that there was definitely no growth, right? There was no change in the number of steps that this person walked in each day for 5 days for the first week. And what that would then mean is our rate of change is supposed to then be 0. Now let's look at, if we're to write this as a model, which would then be an equation, how would then this look like? So with our equation, it means that the equation will then be steps is equals to just 5,000, right? What does that mean? It means in each day, you are just walking 5,000 steps. No change whatsoever. So this is one example of when there is really no growth that is taking place here, or when there is no change that is taking place. Now, let's look at if they just spice things up a bit. They take a weekend off, which is our day 6 and 7, and then they start with day 8. Day 8, they say they now need to walk 5,000. Remember, the goal is to get to 10,000 steps a day for health purposes. On the 9th day, they walk 5.1. Was there a change there? Think about that. On the 10th day, they walk 5.2 steps. Was there a change from the 9th day to the 10th day? Think about that as well. And then on the 11th day, they walk 5.3 steps, so 5,300. You look at, is there a change between day 10 and day 11? And then lastly, on day 12, they walk 5,400. You also think about, is there a change there? So you can see that there was a change of plus 100 steps. There was a change of plus 100 steps. There was a change of plus 100 steps. There was another change here of plus 100 steps. Now, excuse me. Now remember, with this, we are busy talking about a simple pattern. A simple pattern means that there is a constant change of whatsoever that is happening. In this context, there is a constant change of the number of steps that the person is adding in each day as they are progressing with their health journey or with their walking, right? And specifically, that will be 100. So what does this then mean? What you need to think about right now before we go to the next thing would be, what would then be the rate of change? Or how would we find our rate of change? How will the equation, the model that we need to use to predict what will happen in future, what will then it look like as well? So that's what you need to please be thinking about. Now you can see here that the person started on day 8 with 5,000 steps, and then on day 9 they went to 5.1. On day 10 they went to 5.2. On day 11, they went to 5.3, and then on day 12, they went to 5.4, right? And if I was to draw a graph, this is how the graph will look like. So already you can see that I have a gradient here, right? So this will have a gradient, which will mean the steepness of this thing is exists here. Now let's look at if I wanted to calculate my gradient. So my gradient will be change in steps, right? And you divide this by change in days. Now you will see that change in steps, let's look at 5,400 minus the initial, which was the 5,000, and we will divide this by, they walked 5,400 steps on day 12, so that's 12, minus they walked 5,000 steps on day 8, which means that's 8, and therefore this will be equals to, if you subtract there, it will be 400 over 4, which will then be 100, right? So as we saw that with the previous table that we were using to explore this state, there was a plus 100 that I was adding in each day. So that's what the gradient tells us. What was the rate of change? How was it changing due to the number of days that we were looking at? Now let's try and develop a model that we will use, which in this instance will be an equation that we will use to try and talk about this. If I want to find the equation here, I will then say my equation is going to be the steps will be equals to my gradient, which is then the 100 multiplied by d. The d represents number of days, then plus the initial number of days that the initial number of steps that the person walked. So maybe let's look at day 8, right? So in day so if you look at maybe day 8 here, you will then say that this is going to be 100 times that plus that. So you would be looking at what exactly does it mean to try and find the number of steps that the person will walk in each day that we are trying to talk about. So that's the big idea here. So the big idea here, one is there is definitely a change. Is the change constant? Okay, true, it is constant. Number 3, can we develop a model to predict what will happen maybe let's say in day 20 if this person continues to walk the very same thing that they are doing? True, yes, it will be there. And then lastly, what will then be the rate of change in terms of the number of days that they're doing this? And if I was to predict here, then it would mean you will then know to say in a certain number of days that the person has walked, this would be the number of steps that they would have walked in that duration altogether. So that's the big idea here that we are trying to talk about. And then also it will be how many days did they walk, and then you try and use that to talk about how many steps did they actually walk for all those days or for a specific day in particular. But going back to the previous one, you can see that with the previous one that I looked at here, all right, so let's just quickly do this. With the previous one that we looked at, we saw that there was definitely no growth that was happening here, right? So if we were to predict on this, to say if this person, they want us to know on day 10 how many steps the person will walk, if this was the graph that we are dealing with, then we will definitely say that they will walk 5,000 steps because there is no change that is taking place. And the number of steps is a constant value as you are progressing through, because remember our gradient was 0 there. And then on day 20, how many steps will they walk? Think about that. On day 50, how many steps will they walk? If this is the nature of our graph, and this is the nature of information that we know. But if we go to this one here, you can see that there is a gradual increase which was plus 100 each and every day. So you can then tell us that if I want to find what the number of steps is, maybe on day 15, I can use the model that we'll develop here to try and talk about that. And then that will give us the two relationships that we're looking at. So this is a perfect example of what growth means. Remember, we're still looking at the big idea, which is growth, right? So this person, will this person reach then their target that the doctor has recommended for them? True, they will in this second scenario. But in the first scenario where they just said, okay, I'm just gonna walk 5,000 steps in each and every day, they will not get to 10,000 steps a day. And that would have been maybe the recommendation from the doctor. But with this second scenario, they can then get to that. So this will be a perfect example of what we are talking about when we're saying there is growth. The first one will be a perfect example of a very opposite thing to what it means to have growth in this particular example. So that's what we are actually trying to look at with the big idea. Remember, just to summarize what we've looked at so far, our big idea is growth. Under growth, we're looking at a pattern. Under a pattern, we're looking at a simple pattern. Simple pattern, what does it mean? It means our growth is constant that we are measuring. The rate of change is a constant rate of change as we are progressing with our growth. And then we can then develop a model that will help us to predict in the future what will happen if we wanted to know. And that's it from me for now. We're gonna go to a quick ad break and we'll be back just now. Stay tuned. Hi guys, welcome back to the show. So we are going to now do some mathematics now. So remember, the very first thing that we looked at was to look at growth in the context of society. And then we looked at growth in the context of a pattern. Now we're going to look at growth in the context of finance, right? Which is then describing growth in terms of mathematics. Remember the three questions that I said you must think about. Describing growth, what is growth? Number two, describing growth in words. Number three, describing growth using maths, right? Or in mathematics. So that's what we are actually going to look at now. So let's just go and do it. Now remember, our big idea is growth, and then we're looking at patterns under growth. In particular, now we're going to look at finance. The keywords that you just need to think about will be the concept of savings. So savings, you know, we teach you this at a very young age to say, okay, put away 2 rands, and then you know maybe by end of the month you will be having this much to do something with. And then with an investment, this would then be a long-term thing, meaning if you're trying to save up for university one day, so you save up for a long term, the principal amount will then be what you start with, right? So this is what you start with, right? I will just write start with here. That will be our principal amount. Accumulated amount will be the growth now in this instance, right? The growth. So growth in terms of what you started with, what did it grow to be? And that's what the accumulated amount is. Interest will be how much is it growing by, and then interest rate will be over time. What exactly is the rate that they are giving you in terms of looking at this particular growth? Now, let's just explore a few savings values here. So month 1, the person says, now I want to save up 500 rands. So maybe you might be trying to say, let me look at, I want to buy a console, right? Or I want to buy myself a cell phone so that you can watch our shows. What you will then do would be save some money each and every month, and that money will accumulate to be a bigger amount of money that you can then take out and do what you want to do with that. So this will be if you want to buy something that's really, really expensive, and then you decide to say, instead of me maybe buying it in one go, let me save up for it for a certain period of time. And then that's what this example is all about. So first month, the person saves 500 rands. Second month, they save 510 rands. Remember our question that we always ask ourselves: is there growth? Is there change from 1 month to the next month? Third month, the person saves 520. Is there growth? Is there change? Fourth month, 530. Is there change? Is there growth? 540. Is there change? Is there growth? So that's what we need to look at. So you can see there that this changed with 10 rands. That also changed with 10 rands. That also changed with 10 rands. And that also changed with 10 rands. So it is a constant change. Now you can see that immediately it's a constant change, it's a simple growth. Immediately it is not a constant change, we'll then maybe look at if it's a compound growth or it's just a random growth or no growth for that matter. Now, if I put this on a graph, this person on the first month, they started with 500 rands. And the second month, they went to 510 rands. The third month, 520. The fourth month, 530. The fifth month, 540. And the graph for this will look something like that. And then if I want to look at what my gradient is here, it will be the change in the total, which I will just say is delta T, over the change in months, which will just be M in this instance. So this will be, they had 540 minus the 500 divided by the 540, they had it on day 5. The 500, they had it on, on month 5. And then the 500, they had it on month 1. So this will then be equals to 40 over 4, which is then equals to 10, as you saw with the previous example on the table. If we want to find then the equation for this, the equation for this will be, if we want to know what our total is, we will then say, what is our growth? Our growth is 10 multiplied by the number of months, right, plus the initial amount that the person started with, which was the 500. So if I want to know what was the total for, say, maybe month 2, right, this is going to be 10 times the 2 there, and then plus that. So that will give me what was the total on month 2, and then, okay, so this will be 10 times 2 plus that much, and then you can then find that it's going to give me 520. So that's what the example is here, and that's how our equation will then look like. We're going to write this equation using math just now. Now, if we want to calculate the rate of interest now that we are dealing with, would be the very same example. Remember that the person was having 10 rands that is added every day, right? 10 rands. So it means if I want to calculate this, it means the person started with 500 rands and they were adding 10 rands of that, right? So you need to know what the percentage of this is, which will then be equals to, so you know that those will go away, therefore I have 2%. So this in simple terms means that it's 2% of the original amount that the person is adding. But because this is simple growth, it's not 2% of what you have in the bank, if you are using the bank maybe, but it is 2% of what you started with. So with simple growth, we're only looking at the percentage of the initial amount that you started with, and that's what you are adding in each and every month. Whereas if we go to compound, which we will go to at a later stage, will then be the percentage, this 2%, if we're dealing with it, will be 2% of what you have in the bank at that time, or in your piggy bank at that time, right? So that's what we are trying to look at here. But simple growth It's 2% of the initial amount that you started with. And that's what we are looking at. Now, let's just look at a specific question that we can try and look at, right? So Sipho buys a notebook for 2,500 rands, right? And then he pays a deposit of 250 and then agrees to pay off the balance in equal installments. Now we first need to know what our balance is, right? So the balance in this instance will be the original price minus the deposit, right? And then our original price was 2.5 minus the deposit, which was 250. And that will give us 2,250. And that's what will then be the balance that the person is going to pay off in equal monthly payments over 10 months. But the shop manager then says, instead of you just paying that 2,250, I'm going to charge you 5% simple interest each month. Remember, simple interest is what? Simple growth. Now let's just go to the previous slide and quickly talk about this. So when I'm talking about simple interest, the simple interest will be given by the formula A, which represents our accumulated amount, and this will be equals to P, which is the principal amount that we are dealing with, plus, right, the P that we have here multiplied by I, which means that the interest that we are dealing with multiplied by N, right? So it will be the interest of whatever the initial amount is that we have multiplied by the number of years or months that I'm getting the interest. Let's make an example. If we are going back to the previous example where the person is saving 500 rands, right? It will be 500 rands plus the 500 rands. Remember, we found that it was 2% of this, right? So 2% of this multiplied by, they saved up this thing for how many months? For 5 months, right? They saved this for 5 months. So you can see that if you were to multiply this, 2% of this, remember, was 10, and then multiply this by the 5, and then plus this 500 rands here, this will then give us 550, right? So this will give us 550. But this 550 will have to minus 10 rands from it, because remember, the first month they started with putting in the bank 500 rands. So that's why we're going to minus that, which will then give us the 540. So in actual fact, our formula will be given by A is equals to 1 plus the interest multiplied by N, which will be the number. So if I take out the P as a common factor there, this will then be what I will be left with. So this will then be the formula that we are going to be using with you to try and talk about what it means to have growth. But I need you to understand something with growth, that growth does not only apply to investment and also savings. It also applies to if you take something on, the concept would be a hire purchase, right? Hire purchase in terms of you borrowing money, or like in this instance, an agreement that you have with the store manager that I can't buy this thing for 2.5 now, but I can only pay 250. Can I please pay the remainder on a monthly basis? That's what this talks about. There is a growth that will need to happen in that amount that the store owner says you still need to settle, and then you will be paying that over a certain period of time. Specifically here, we're talking about paying it off in 10 months. So let's quickly just look at that question, right? So the first question says, how much money or how much must Sipho pay each month? So firstly, before we can look at how much Sipho must pay each month, we must first look at how much will the interest be on this amount that we have here? So the interest of this amount that we have here, right? So the interest of the amount that we have here, which is our 2,250, was 5%, right? So the very first thing we need to do is to look at what is 5% of the amount that we have, 2,250, and then we're going to add whatsoever that 5% is, we add it to the original amount, which is the 2,250. And then whatever we get there, we're going to divide it by the number of months that the person needs to pay. And that will give us how much the person needs to pay on at the end of each month for the 10 months. And then what did Sipho pay for his notebook? So what does that mean? It means you will then need to look at how much did Sipho pay at the, every month, multiply by that 10, and that will give us how much Sipho paid each and every month, and at the end of the duration of his agreement with the manager. So that's what the concept of simple growth is all about. Remember, guys, simple growth does not only apply to investment or savings. It also applies to agreements that involve you taking something maybe on a loan, because this is roughly a loan, although it does not specifically say that it is a loan, but it is actually a loan, because you can only pay a certain portion of it, and then the remainder you can only pay it over a certain duration of time or period of time. And that's what we will then be talking about in terms of growth and all of that. So just to summarize quickly what we're looking at, remember our big idea, guys, was growth, right? Under growth, we looked at the concept of patterns. Patterns is the change. Is the change constant? Can I then form a model that I can use to predict anything going forward? That's what we're looking at. And then we then looked at this in terms of society. Our main example here was the growth of babies in terms of weight over a 30-month period, right? And then we also went further to look at finance. With finance, we're looking at now, if you were to save this amount of money, what will happen? If you were to buy this at a certain price, but you can't afford to pay the whole amount, what must you do? Must you rather wait and save for 10 months and only buy it after 10 months, or must you still take it? It's one of those decisions that you need to make. And then our quick summary is, when we study growth, we measure one, change, right? Is there a change in the pattern? Also, what will then be the rate of change? And remember, our rate of change will be the concept of what we are talking about when we talk about gradient and the steepness of a line. All right, so that's all that we are talking about, guys, right now. Simple growth, remember, it's the same as simple interest, which we'll look at and explore at a later stage. But the goal that we wanted you to please see here is there a change? Is the change constant? What would be the rate of change? Can I then work out a model in terms of either a graph or an equation that will allow me to predict what will happen after 10 months, after 3 days, after 5 days? You saw our example of walking, our example of saving a certain amount of money each and every day. That's what we are talking about here. So that's all from me, guys. See you next time. But for now, bye, everybody.